So today I am explaining the concept of symbols of BJT. BJT means bijunction transistor and its configurations. So let me explain the symbols of this transistor, these two transistors. So this is emitter, base, and collector. The how to identify the emitter means suppose this arrow here, the arrow indicates emitter, whether it may be into the directions, into the BJT, into the arrow inside, going inside the BJT, or arrow outside, coming outside the BJT. The arrow indicates emitter. Here this is emitter and this is also arrow, since it is arrow emitter. So arrow into the base is P type. That means arrow into the base. That means the current. It's a direction of the current. The current is entering into the base. It is called emitter. Similarly, this is arrow going out. That means this is called current outing. Current is emitting. That means it's outing up from the BJT. This is what is called as a NPN transistor. This is, since it is a P, means PNP. That means emitter is P type, base is N type, collector is P type. Since it is outing, that means emitter is N and the base is P and N is collector. That means so emitter and collector are both. So since it is P, then collector should be P, and since it is N, emitter is N here and the collector is also N, but the base is different from this emitter and collector, and E for emitter, B for base, and C for collector. And coming to the different types of configurations, here this is the base and emitter and collector. So since the base is common for both this part and this part is called as input port and this part is called as output port. So since it is common, means it is a common base configurations, and PNP, this is PNP type mode of common base configuration, and this is giving this positive volt is given to the P side and negative volt is given to the N side. This is what is called as active region. Since input port is connected in forward base and output port is connected in the reverse base, this is what is called as active region. And similarly, if this is connected in, this is negative is connected to this and negative is also connected to this. That means this negative is connected to this. So this is what is called as a cutoff region. That means this is negative and negative. That means this is reverse bias and this is also reverse bias. This is what is called as a cutoff region. Both input and output both are connected in reverse bias. Next, coming to this is connected in positive, negative, and this is also connected in positive, negative. This is what is called as a saturation. Both input is connected in forward bias, output is also connected in forward bias. This is what is called as a saturation region. So that means if the input is connected in forward bias and output is connected in reverse bias, active region. If the input and output both are connected in reverse bias, this is what is called as cutoff region. And if the input is forward bias and output is also forward bias like this, and it is called saturation region. So coming to the common collector, here collector is connected to some voltage. So here it's somewhat it is difficult to understand, as in the case of not as in the case of common emitter, and means it's very difficult to understand, because in the common emitter and common base very easy to understand, but here the common collector, but it's not directly grounded, it's giving some voltage here. So some voltage is nothing but giving is nothing but also grounded. Why? Because the ground can be a positive or a negative. So that's why here the emitter is connected to some resistance Re, and which is connected to the ground. So we are taking the output here. We are taking output here. So this is input port. This is the base, emitter, and collector. So VBC is the input port, whereas VCE is the VEC or VC, whatever it may be. So VEC is the output port. So VEC is the output port and VB is the input port. So this is what is called as a common collector configuration. It's a somewhat little bit difficult to understand. And let us coming to the common emitter configuration. And here the emitter, this arrow indicates emitter. Emitter is grounded, and this is emitter, base and collector. So base emitter is connected in forward bias because PNP. So N is connected to the negative terminal, whereas emitter is grounded, and this is also PNP. Here the collector P is connected to negative bias. That means this is part is reverse bias, and this part is input port is forward bias. This is what is active region of common emitter configuration, because here the emitter is grounded. This is part, and if it is connected in forward bias, let it be forward bias, reverse bias. That means PN. That means this is reverse bias. Input port is reverse bias, and output port is also reverse bias. This is what is called as cutoff region. If the both are connected in forward bias like this, because this is N means N, and this is forward bias, and this is what is called as a saturation, because the input port is forward bias, output port is also forward bias. This is called as a saturation region of the common emitter configuration. Coming to this symbols, BJT symbols and configuration, and this is the type of configuration, and these are the input parameters, and these are output parameters. Since we have two ports, input port and output port, so the port contains its voltage and current. Similarly, output port contains output voltage and output current. So for common base configuration, since the base is ground, base is common, so input terminal is the emitter, so that's why it is current IE. Similarly, the input port, since the base is common, the voltage between input emitter and base is called voltage between VEB. So similarly, output current, output terminal is the collector, so the current through it is called as IC, and the output port is between the terminals of collector and base, because the base is common. That means voltage between them is VCB. Coming to the CE, common emitter configuration, here the emitter is grounded, the input terminal is the base, so that's why the current through it is base IB, and the input terminal is between the base and emitter, because the emitter is grounded, that means it is VBE. Similarly, coming to the IC is the output current, because the collector is common, and the output terminal is between the collector and emitter, that's why VCE. Coming to the common collector, here the collector is common, input terminal is base, output terminal is emitter, so it's a base IB, the current through it is IB, and between the base and collector, because the collector is common, input port is between the base and collector, VBC, and this is output terminal is, already we know that it's a emitter, so that's what is called the current through it is emitter IE, and the output terminal is between the emitter and the collector, that's what is called as VCE. So these are the different input and output parameters of the BJT, bijunction transistors.